Hi guys, I hope you all are doing well. In today's video, we will learn about linear functions. Always remember that if a linear function is drawn on the graph paper, it looks like a straight line, okay? Before we start, it is important that you know what do we mean by linear function. So what is a linear function? A function where the degree of the polynomial, the degree or the highest power of the polynomial is 1. If the highest power is 1, it is a linear function. It is a linear function. For example, let's say 2x plus 3y equal to 5, or let's say y equal to 2x, or let's say you can say x minus y equal to root 3. So if you observe in all these three examples, the highest power of the variable is 1. The highest power is 1, and hence we can call them as linear functions. We can call them as linear function. Now when you draw these functions, on the graph paper, they will look like a straight line. They will look like a straight line. For example, let's say this is your Desmos calculator, Desmos graphing calculator. If I write the first equation, 2x plus 3y equal to 5. Now if you observe, this is a straight line. This is a straight line. If you write the other equation, let's say y equal to 2x, you will observe that this is also a straight line. You'll observe that this is also a straight line. And for the third one, let's say x minus y equal to root 3. So if you observe, this is also a straight line. This is also a straight line. So moral of the story is, if you have a linear function, if you draw the linear function on the graph paper, you get a straight line. Okay. So I hope you understood this. So all these three linear functions demonstrates a straight line. Now there are different ways to write the linear function. So linear function can be written in four forms. They can be written in four forms. So we have four forms: 1, 2, 3, and let's say 4. Okay. So the first way of writing is known as the general form. We have a general form. What is the general form of a straight line? What is the general form or of linear function? Let's say the general form is ax plus by plus c equal to 0. Ax plus by plus c equal to 0. Okay. I'll write it other way around. Hold on. So we have linear functions. And there are four ways: 1, 2, 3, and 4. Okay, we have four ways. The first is the general form. What is the general form of a linear function? It is ax plus by plus c equal to 0. Where a, b, c are constant, of course. A, b, c are real numbers. Second is the slope point form. Slope intercept form. What is the slope intercept form, guys? The slope intercept form will be y equal to mx plus c. Where your m is the slope, and c is your y-intercept. So since we have a slope and since we have a y-intercept, we say this is slope-intercept form. You have other form, which is slope point form, which is y minus y1. I'll use another ink, which is y minus y1 equal to m times x minus x1. Again, if you observe, m is here, so m is nothing but the slope, or we call it gradient as well. So m is the slope or gradient, whatever you call it, and x1 and y1 is the point from where the straight line is passing. X1 and y1 is the point from where the straight line is passing. So since we have a slope, a point, we call it slope point form, or you can call it gradient point form, whatever you want to say. Okay. And the last one, which is double intercept form, double intercept form. Okay, how does this look like? How does this look like? This is y upon y intercept plus x upon x intercept, and this is equal to 1. This is equal to 1. Okay, so since we have y intercept and x intercept in the function, in the function of course, since we have y intercept and x intercept, we call it double intercept form. We call it double intercept form. So these are the four forms of a straight line. These are the four different forms of a straight line. Very important, the question can come in any way. For example, let's say the question is find the equation of a line such that now your part number 1 is slope is 3 and y-intercept is 7. Okay, so what will be the answer to this? The answer will be y equal to mx plus c. Y equal to m is 3. It says that the slope is 3. So y equal to 3 times x plus, it says that the y-intercept is 7. So c will be 7. So this will be y equal to 3x plus 7. This will be y equal to 3x plus 7. So this is your answer. Now let's say the second question is find the equation of a straight line such that the slope is 3. The slope is 3 and it passes through 1 comma 2. It passes through the point 1 comma 2. So we have a slope which is 3 and we have a point which is 1 comma 2. So we have slope, we have point, so you can use slope point form. So this is going to be y minus y1. So if you observe this point over here, x1 is 1 and y1 is 2. Okay, x1 is 1 and y1 is 2. So y minus y1 equal to m times x minus x1, equal to m times x minus x1. So this is y minus 2 equal to slope is 3. So 3 times x minus 1. So 3 times x minus 1. Now you can leave the question, you can leave the answer here. You can leave the answer here. Or someone will tell you, I want the answer. Okay, I'll write the other question. Write the above equation in general form. So what is the general form? The general form is ax plus by plus c equal to 0. Okay, now your equation of the line is y minus 2 equal to 3 times x minus 1. So let's simplify this. This becomes y minus 2 equal to 3x minus 3, shift 3x on the other side, so it becomes minus 3x plus y minus 2 equal to minus 3. Shift minus 3 on the left hand side too, so it becomes minus 3x plus y, and 3 minus 2 will be 1, so plus 1 equal to 0. So if you observe, this form over here is the general form. So minus 3x plus y plus 1 equal to 0. So this is how you can write it. Or someone might ask you, this is question number 4. Okay, find the equation of a line such that the y-intercept is 2 and the x-intercept is 3. So how do you write it? You will write this as x upon x-intercept plus y upon y-intercept equal to 1. So x upon 3 plus y upon 2 equal to 1. So this is your double intercept form. So what I mean to say is the fact that the straight line can be written in any one of these four forms. It can be written in any one of these four forms. Okay, now let's move ahead. Let us move ahead. There is a term that we have used very oftenly in all the four forms. Okay, the term that we used was m. What is m? M is your slope or gradient. M is your slope, or you call it as gradient. Okay, now the question is, how do we find it? So always remember, the slope m is nothing but rise over run. It is rise over run. Very, very important. Now let us derive a formula for the slope. Let us derive the formula for the slope. Let's say, let's draw the Cartesian plane. Let's say this is your Cartesian plane. Let's say this is your y-axis, this is your x-axis, and this is your origin 0. Okay. Now let's say you have a straight line. Let's say you have a straight line like this. You have a straight line like this. Let's say you have 2 points on the straight line. Let's call this point as A and this point as B. So let's say this is A, this is B. Let's say the coordinates of A are x1 and y1. The coordinates of B are x2 and y2. The coordinates of B are x2 and y2. Okay. So guys, we have to find the slope of this line. We have to find the slope of this line. Can I say that this distance, so distance of point A from the y-axis, this highlighted part, can I say this distance is x1? Can I say this distance is x1? This will be x1 because the x coordinate of point A is x1 y1. The x coordinate of point A is x1 y1. So can I say this is x1? Yes, I can say that. Similarly for B, can I say that this distance is x2? Can I say this distance is x2? Right? So what will be this distance? What will be this distance? So guys, this distance over here will be x2 minus x1. It will be x2 minus x1. This distance will be x2 minus x1. Similarly, can I say that this distance over here is y1? Can I say that this distance is y1? Of course I can say that. And can I say that this distance over here is y2? Can I say this distance is y2? Yes, so this distance is y2. Why is it y2? Because the y coordinate of point B is y2. So this whole distance will be y2, right? So can you tell me what will be this distance? What will be this distance? This distance over here will be y2 minus y1. This distance over here will be y2 minus y1. Now if you observe, I have a right angle triangle. Okay, let us call this point over here as O. Okay, let's not call it O because it might confuse you with origin. So let's call this point as C. And what is the formula for gradient or slope? Okay, we have just learned that M. Okay, hold on just a minute. I'll erase this part so that I have some space to write. Okay, this is your y-axis. Yeah. Okay, so what is the value of M? So if you remember, I taught you that M is rise over run. So what is the rise, guys? What is the rise? The rise is y2 minus y1. The rise for this line is y2 minus y1. So the rise is going to be y2 minus y1. And what will be the run? Guys? If you observe, this will be your run. Run will be x2 minus x1. So run will be x2 minus x1. So the formula for finding the gradient or the slope, this is how you find the gradient, or whatever call it, slope, whatever you want to call, gradient or slope. The formula is y2 minus y1 divided by x2 minus x1. Now if you observe, if I say this angle over here is theta, then what is y2 minus y1 upon x2 minus x1? Can I say it is opposite upon adjacent? Yes, I can. So basically this is nothing but tan theta. So M is rise over run, which is nothing but y2 minus y1 upon x2 minus x1. And this is nothing but tan of theta. Now guys, if this angle is theta, can I say this angle over here is also theta, this angle over here is also theta, right? Because corresponding angles, this angle is also theta, right? Which means if I take the tan of the angle at which the line is inclined, I get the slope. If I take tan of the angle at which the line is inclined, we get the slope. Okay, so for now remember that slope is rise over run, which is y2 minus y1 upon x2 minus x1, and it is equal to tan of theta. It is equal to tan of theta, where theta is the angle at which the line is inclined. Where theta is the angle at which the line is inclined. Okay. Now slopes can be of four types, right? Let's say I'll draw the four options. Hold on. I'll draw the four options. Let's say this is your y, this is your x, this is your second option. Let's say this is your y, this is your x. Third option will be here. Let's say this is your y, this is your x, and this will be your fourth option. This will be your fourth option. You will say this is your y, and you will say this is your x. Okay. I hope you can see it properly. Now let's say the line is something like this. Let's say the line is something like this. In this case, the slope is positive. In this case, the slope of the line is positive. The slope of the line is positive. Now let's say if the line looks something like this, the line looks something like this. In this case, the slope is negative. In this case, the slope is negative. Let's say your line looks something like this. Let's say your line looks something like this. In this case, your slope is 0. In this case, the slope is 0. And let's say your line looks vertical. Let's say you have a vertical line. Okay. So in this case, the slope is 1 divided by 0. The slope is not defined. The slope is 1 divided by 0. The slope is 1 divided by 0. Okay. So either you memorize this, or I have one more way. Let's say you have a line. Let's say you have a random line. Okay. Now how to find if the slope is positive or negative? Draw a small plus sign. Over here, anywhere on the line. Okay. If the line is passing from the first quadrant and the third quadrant, then you say that the slope is positive. Okay. Second way is, let's say you have a line something like this. Again, draw the plus symbol over here. I have drawn it. Now, if the line passes through the second and the fourth quadrant, then in that case, the slope is negative. Always remember, for a horizontal line, the slope is 0. And for a vertical line, the slope is not defined. It is 1 by 0. For vertical line, the slope is not defined. It is 1 by 0. Now, since you know it, can you tell me what is the equation of x-axis and y-axis? What is the equation of x-axis and the y-axis? That's your question. So let's write the equation. So y minus y1 equal to m times x minus x1. Okay. For x-axis. So if you know, x-axis is a horizontal line. Right? So slope will be 0. I have just taught you that for horizontal line, the slope is always 0. So if the slope is 0, then in that case, y minus y1 will be equal to 0 times x minus x1, which means y minus y1 will be equal to 0. And x-axis passes through origin, right? X-axis, if you draw the Cartesian plane, which is something like this, okay, it passes through 0, right? X-axis and y-axis, both of them passes through 0, 0, right? So y1 is 0. So basically, y equal to 0 is your equation for the x-axis. Y equal to 0 is the equation for x-axis. Similarly, for y-axis, the equation comes out to be x equal to 0. So let's say if you have a line parallel to x-axis, so the equation of the line parallel to, let's say, y-axis, parallel to y-axis will be x equal to constant, right, where constant is the point from where the line is passing. What I mean to say is, let's say you have a Cartesian plane something like this, okay, and now the line is parallel to the x-axis. Let's say this is your y, this is your x, no, sorry, not x-axis, y-axis, sorry. Let's say if your line is parallel to the y-axis, so let's say you have a vertical line something like this, and let's say it passes through the point 3 comma 0, it passes through the point 3 comma 0. Okay, so the equation will be x equal to 3. The equation of this line will be x equal to 3. It will be x equal to 3. Similarly, the equation of the line parallel to x-axis, the equation of the line parallel to x-axis will be y equal to constant, where k is again the point from where the line is passing. What I mean to say is, let's say if I draw the Cartesian plane something like this, let's say this is your y-axis, this is your x-axis. Now you have a line which is parallel to the x-axis, so the line is something like this, and it passes through this point, and the coordinate of this point is, let's say, 0 comma 5. It is 0 comma 5. So what will be the equation of this line? The equation of the line will be y equal to 5. The equation of this line will be y equal to 5. So very easy, guys, very easy. I hope you will remember this. So these are few examples. Now let us talk about parallel lines and perpendicular lines in general. But before that, it is important to know the angles between two lines. Or what we can do is, let us learn parallel lines and perpendicular lines first, and then we'll go to the angles between two lines. So let's say if I draw the Cartesian plane here, hold on. Yeah, this is your y-axis, this is your x-axis. Okay, now let's say you have a line something like this. Let's call it L1, and the slope of this line is M1. Let's say the line is L1 and the slope of this line, or the gradient of this line, is M1. Let's draw another line which is parallel to it. Call it line 2. And let's say the slope of this line is M2. So what is the relationship between M1 and M2? So guys, I hope you remember that I have taught you that the slope or the gradient, whatever you call it, is rise over run, and which is nothing but tan of theta. Where theta is the angle at which the line is inclined. Which means if I say this angle over here for line M1, let's say if the angle at which line 1 is inclined is alpha. Okay, let's say the line at which L1 is inclined is alpha, and let's say the angle at which line 2 is inclined is beta. Let's say this angle is beta over here. Can I say alpha is equal to beta? I mean, since the line L1 and L2 are parallel, since L1 is parallel to L2, alpha will be equal to beta. Why is that? Because of corresponding angles. Okay, so guys, since alpha is equal to beta, can I say that tan of alpha will be equal to tan of beta? And what is tan alpha? Tan alpha will be the slope of line L1. alpha is the angle at which L1 is inclined. So if you take tan of alpha, it will give you slope, right? That's what we have learned. What have we learned? We have learned that slope or the gradient is tan theta. So tan of alpha will be slope of line 1. So I'll say this is m1, and tan of beta will be slope of line 2. So m1 equal to m2, m1 equal to m2. So always remember, for parallel lines, the slopes are same. M1 will be equal to M2. The slopes of parallel lines are same. We have a video where we have done a lot of questions on straight lines. So to master this concept, we have done few questions in that video of straight lines practice questions also. So you can watch that video and you can see how we solve the question based on this topic. Okay. Now for perpendicular lines, what will happen? Let's draw the Cartesian plane. Let's say this is your y-axis, this is your x-axis, and this is your origin. Let's draw a line. Let's draw a line, and let's draw a line perpendicular to it. Let's draw a line perpendicular to it. So we know that the angle between these two lines, is 90 degree. This is 90 degree. Okay. Now let's say this is your line L1 and the slope of this line is M1, and let's say this is your line L2 and the slope of this line is M2. Let's say the slope of this line is L2. What is the relationship between M1 and M2? What is the relationship between M1 and M2? Let's say your line 1 is inclined at an angle of alpha. So let's say this angle is alpha. And let's say your line 2, I'll use another color if you wish. So let's say this angle over here, the angle at which line 2 is inclined is beta. So can I say that beta minus alpha is 90 degree? What I mean to say is, this angle is beta, so this big angle is beta, and this angle is alpha. So can I say that beta minus alpha is 90 degree? Can I say beta minus alpha is 90 degree? Of course I can say that. Right? If you want, I'll pause here for 2 seconds. You can look at the diagram, you can pause the video, and you can think or you can imagine if beta minus alpha is equal to 90 degree is right or wrong. I'll leave this up to you. Okay, but yeah, beta minus alpha is 90 degree. So let's take tan on both the sides. So let's say this is tan of beta minus alpha equal to 90 degree. Tan of beta minus alpha equal to 90 degree. Now there is a formula for tan of a minus b. Tan of a minus b is tan a minus tan b divided by 1 plus tan a tan b. Okay, so this is the formula which you must have learned in trigonometry. If not, you can learn it right here. This is the formula for tan a minus b. So I'll use it here. Okay, hold on, there is a silly mistake. I have written 90 degree here. It should be tan 90 because you took tan on both the sides. So this is not 90, this is tan of 90 degree. I took tan on both the sides. So you have tan of beta minus tan of alpha divided by 1 plus tan beta into tan alpha equal to tan of 90, which is 1 by 0. Tan of 90 is 1 by 0. Now guys, if you observe the diagram, can I say that M1 is tan of alpha? This is tan alpha, because the angle at which line 1 is inclined is alpha, right? So can I say M1 is tan alpha? Of course I can say that. And can I say that for M2 this is tan of beta, because the angle at which line 2 is inclined is beta, so tan of beta will be M2. So M1 is tan alpha, M2 is tan beta. I'm going to substitute it over here. So this becomes M2 minus M1 divided by 1 plus M2 into M1, and this is equal to 1 by 0. It simply means that the denominator is 0. The denominator is 0. So can I say that 1 plus m2 into m1 is equal to 0? So can I say m2 into m1 is equal to minus 1? I mean, you can say this is m1 into m2 equal to minus 1. Whatever you say, it's one and the same thing. So can I say m2 is negative 1 by m1? Can I say m2 is negative 1 by m1? So for perpendicular lines, the slope of the other line is negative reciprocal of the first. The slope of the other line is negative reciprocal of the first one. Okay. So guys, I hope you understood. I hope you understood this. Now let's move to a very interesting topic, which is how to find angle between two lines. We will learn how to find angle between two lines. Okay, so let's draw the Cartesian plane. Let's draw the Cartesian plane. Let's say this is your y-axis, this is your x-axis. Let's draw a line, call it L1, and let's say the slope is m1. Let's say the line is L1, the slope of this line is m1. And let's draw another line, which is this. Let's say the line is L2 and the slope is also L2. Let's say the slope is the line is L2, the slope of this line is also L2. Let's say the angle at which L1 is inclined. Okay, I'll use the thicker ring. Let's say this angle over here at which L1 is inclined is L1, alpha, not L1, alpha, my bad. So let's say the line at which L1 is inclined is alpha, and let's say the line at which L2 is inclined is beta. Let's say this is beta. Okay, so can I say from this diagram, can I say alpha minus beta will be the angle between two lines? Can I say the angle between two lines, let's say the angle between two lines, which is this, so this angle over here, can I say this angle over here is nothing but alpha minus beta? Can I say it is alpha minus beta? Yes, I can say that. So this is alpha minus beta, right? So angle between two lines, let's say the angle between two lines is theta. So let's call this as theta. So I'm saying angle between two lines, angle between two lines is theta, So can I say alpha minus beta is theta? Can I say alpha minus beta is theta? Yes, I can see that. Take tan on both the sides. So tan of alpha minus beta is equal to tan of theta. Tan of alpha minus beta is equal to tan of theta. So I hope you know that tan of A minus B is tan A minus tan B divided by 1 plus tan A into tan B. Okay, so this is equal to tan of theta. This is equal to tan of theta. Now, what is tan alpha? What is tan alpha? Can I say m1 over here is tan alpha? Can I say m1 is tan alpha? Because the line L1 is inclined at an angle of alpha. So if you take tan of that, then it will become, tan alpha will become the slope of line L1. It will become slope of line L1. Similarly, what will be m2? What will be m2? The line L2 is inclined at an angle of beta. So if you take tan of beta, then it will give you slope of second line. It will give you slope of second line. So m1 is tan alpha, m2 is tan beta. Let us substitute it over here. So you get m1 minus m2 upon 1 plus m1 into m2 equal to tan of theta. Now, since we want acute angle between these two lines, let's say if you want only acute angle between these two lines, this value should be positive. This value should be positive. That's why I'm using mod. That's why I'm using the modulus. That's why I'm using the absolute value for the function, which means theta will be tan inverse of mod of m1 minus m2 upon 1 plus m1 and m2. So guys, if you have two equation, if you have equation of two lines, it means you will have the slopes of those two lines. It will mean that you know the slope of those two lines. And if you know the slope of those two lines, you can find the angle between those two lines. You can find the acute angle between those two lines. This is the formula. Now, there are two more concepts that I want to discuss in this video, and then we'll stop. Let's say you have a straight line. Okay, and let's say you have a point P whose coordinates are a comma b. Okay, not a comma b. Let's say the coordinates are h comma k. Let's say you have a point P and the coordinate of that point P is h comma k. And let's say you have a line L1 whose equation is ax plus by plus c equal to 0. Okay, my question is how do I find the perpendicular distance of this point P from line L1. Okay, from line L1. So the perpendicular distance between point A and the line can be given by the formula. It can be given by the formula. Let's substitute h comma k over here. So the formula is ah plus bk plus c divided by square root of a square plus b square. And you will take the modulus of this because the distance is never negative. So what have I done? I have just substituted the point over, I have just substituted this point over here. And then I got ah plus bk plus c after substitution. And then I divide it with a square plus b square root. Then I divide it with the root of a square plus b square. So I hope you got this. This is how you find the perpendicular distance between a point and the line. Now the second and the most important concept. Let's say you have two parallel lines. Let's say the equation of first line is a1x plus b1y plus c1 equal to 0. And let's say the equation of the second line is a2x plus b2y plus c2 equal to 0. Okay. Now my question is, how do you find the perpendicular distance between these two parallel lines? How do I find the perpendicular distance d between these two lines? So how do you find that distance? There is a formula for that again. So the formula is distance d will be c1 minus c2 divided by square root of a square plus b square You will take the modulus of this because the distance is never negative. And that's how you find the distance between two parallel lines. With this concept, I conclude the discussion for the chapter linear functions, which is straight lines. I hope you understood a lot of things. In fact, you understood everything from this video. If not, drop a comment and I'll help you for sure. I hope you learned a lot of things. I hope you enjoyed learning with me. So do like, do share, and do subscribe my channel. That's it for this video. Thank you.